Hello guys, welcome back to my channel. If you're new here, on this channel I'll be doing IGCSE Physics related content. So I'll be doing past papers, topic questions, and overall revision. So for this video, most of you guys asked me to do plan and all of IGCSE Physics paper 6, plan and investigation question. So today I'll be going through every type of planning and investigation question for paper 6, which is alternative to practical. So make sure to watch until the end. So the first question asks us, a student wants to investigate the motion of a ball through the air. Plan an experiment which will enable him to investigate how the range of the ball, depends on the angle which it's launched at. So from this statement we can see that the range of the ball is the dependent variable, or it's the variable that's measured. And they also asked us how it depends. So we know that the range of the ball is a dependent variable. The range is the horizontal distance the ball travels after leaving the end of the channel shown. So this is the end of the channel. So the range is how much the ball travels after leaving this channel. So the apparatus available includes a flexible channel. So we have a flexible channel, as seen on the diagram, which can be bent at different angles, and a selection of balls, each of different mass and diameters. So we have different types of balls. And in your plan, you should list any additional apparatus needed. And the second one, explain briefly how you would do the experiment. You may add to figure 4.1 if it helps your explanation. Point 3, state the key variables to keep constant. So over here, we have to state the constant variables. Point 4, draw a table with column headings to show how to display the readings. And point 5, explain how to use the results to reach a conclusion. So for these types of question, I highly recommend you to tackle every bullet point individually at once. So first, let's look at the first one. List any additional apparatus needed. So now, let's understand the investigation first, or how it's going to do. So first, we need a ball. We have a ball over here, and then it's going to be rolling down, and then it would go up. And then after a while, it's going to fall down, and then we have to measure the distance from at the end of the flexible channel to where the ball has landed. So this is the range. So to measure the range, we obviously need a meter ruler. So that's one of the apparatus. We need a meter ruler. And the second one is we want to know how the range of the ball differs with different angles. So we need a way of measuring the angle. So we can use a protractor between the flexible channel and the bent part of the flexible channel. So we need two additional apparatus, a ruler and a protractor. So we can just write additional apparatus. Apparatus would be protractor and a ruler. We've completed the first bullet point. And the second one, explain briefly how to do the experiment. You may add to figure 4.1 if it helps your explanation. So first we have to have like an initial angle for the ball to be launched. So, and then we roll the ball across the flexible channel. And then after it has landed, we measure the distance between the ball and the end of the flexible channel. So as method, firstly what we have to do is we have to have an initial angle, and then roll the ball, and then after the ball has landed, we can measure the range. But then one problem is the ball could bounce. If the ball bounces, then the measurements would be inaccurate. So one way to prevent this is we can make sure that the ball lands on sand. And then we can have a sand surface for the ball to land on. If we have this, then we can be sure that even if the ball bounces, we can see the initial place where the ball has landed. And then we finally measure the distance, measure the range, or the distance between the flexible channel and the ball. So measure the range. And then we have to repeat this for multiple angles. So repeat this for different angles. So that's a basic methodology. So we've done the first one and the second one. The third one, state the key variables to keep constant. So for this one, it's an obvious one. The mass of the ball should be kept constant. So mass of the ball should be kept constant. Should be kept constant. And also, when we look at the diagram, the height of the flexible channel should be kept constant. Otherwise, if the height increases, that means a ball would have a higher speed and it could affect the measurement. So the height of the flexible channel should also be the same. So height of flexible channel. Flexible channel should be the same. Channel should be the same. So these are the two variables that should be kept constant. So now move on to the fourth bullet point. Draw a table with column headings to show how to display the readings. And whenever we draw the tables, we are not required to put in any type of measurements or any values. So for the fourth bullet point, we just have to draw the table columns. So we have our table. And then one of them, it's going to be angle. And it's going to be in degrees. We should never forget the units. They also mark the units. And the second one is the range, which could be in centimeters. So we filled the table. So the last bullet point, explain how to use the results to reach a conclusion. So to reach a conclusion, we should see how the angle correlates with the range. So how the angle correlates with the range, or how the range or how the angle changes with the range. So if the angle increases and the range also increases, that means they are directly proportional. But when the angle increases, if the range decreases, that means they are inversely proportional. So this is what we write, and this is how we come up with a conclusion. And then lastly, we can write repeat the experiment. And take the average. Whenever we write this statement, always write this statement because we will get marks for this, at least 1 mark for this. So whenever writing a plan and an investigation question, we have to repeat the experiment and take the average. So this is our final answer. Let's move on to the next one. So this question states, a student investigates the rate of cooling of hot water in a container which has a lid. So whenever we see the term rate, just know it has something to do with time. Plan an experiment which will enable him to compare the effect of lids of different thickness on the rate of cooling. So now we have identified the independent variable, or the variable that's going to be changed. So it's the thickness of lid. So this is the independent variable. Independent variable. And the dependent variable, or the variable that's measured, is going to be the temperature. So how this experiment is going to go is we have different thickness of lids. So different thickness of lids, and then we measure the temperature. So we measure the temperature of the water initially, and then we measure after some time has passed. And then we do this for different thickness of lid. So let's say this could be 2 centimeters, this could be 4 centimeters, and then we could have another one which is 6 centimeters. So we measure the temperature change for each one, for each thickness of lid. And the apparatus available includes a beaker, a supply of hot water, insulating material from which lid can be cut out. And in your plan, you should list any additional apparatus needed. So as I told you before, let's tackle each bullet points individually. So any apparatus needed. So we need a thermometer to measure temperature. So thermometer, and since we have to measure, we're investigating the rate of cooling, that means we need a way of measuring time. So we can use a stopwatch. So a thermometer and stopwatch are needed. Next, explain briefly how to do the experiment, including the measurements to take so that the rate of cooling can be determined. So the measurements to take. So first we have to measure the temperature, and we also have to measure the time. So now we just have to explain how to briefly do the experiment. So firstly, we have to cut out a specific measurement, specific thickness, I should say. Thickness of lid. And then place it on the hot water in a beaker. On the hot water in the beaker. But before this, we have to measure the initial temperature. So this should be put first. Okay, so we have to measure the initial temperature first. So first, measure the initial temperature. Initial temperature of the hot water. And then after that, we cut a specific thickness of lid and place it on the hot water. After that, we set a specific time. So after, let's say after 30 minutes. So after 30 minutes, we measure the temperature again. Measure the temperature. And then do this with different thickness of lid. Then do this with different thickness of lid. That's our basic methodology. So the next bullet point is state the key variables to keep constant. So first, we need the initial temperature to be the same. And secondly, we need the volume of the water to be the same, because if the volume can affect how how cool it gets after a while. So, and volume of water. Water needs to be the same. And then our fourth point, draw a table or tables with column headings to show how to display the readings. So for the table on this one, we will have two columns. So the first one is going to be thickness as of lid. That's going to be our first column. And the second one, from the previous method, we know that we measure the temperature after 30 minutes. So we can calculate the rate of change of temperature. So the rate of change of temperature can be calculated by, we divide the temperature by the time taken. So the temperature by the time. So that means the unit is going to be degrees Celsius per second. So that's a unit, and it's going to be rate of change of temperature. So these are our two columns, the thickness of the lid and rate of change of temperature, which is in degrees Celsius per second. And then it asks us, explain how to use the readings to reach a conclusion. So to reach a conclusion, what we should do is we compare the readings. So we compare the readings if the change in thickness brings a change in rate of change of temperature, brings a change in the rate of change of temperature. So to analyze the data, first we compare the readings, and then we see that if the thickness of the lid increases, the rate of change of temperature somehow increases or decreases, one of them. We don't have to be specific about it. And then lastly, we can write repeat for each thickness and take the average. This is basically free marks. Make sure to always write this. This is how we get free marks on this question. Repeat for each thickness or repeat the experiment and take the average. This will always give you free marks. So we move on to the next one. Now this one is electricity. A student investigates the change in current in a conducting liquid as the distance between two electrodes is changed. The circuit is shown in figure 4.1. So basically what we have to do is we have two electrodes here, and then the student wants to investigate how changing the distance between the electrodes affects the current. So plan an experiment to investigate the change in current in the liquid as the distance between the electrodes is changed. So you should explain briefly how to do the investigation. So let's do this first. So let's understand the experiment first. So basically what we have to do is, first we measure the distance between the two electrodes, and then after that we measure the current in the ammeter. So after we measure that, we get another one, or we repeat for different other distances. So we can make that increase the distance from here to here, or we can also decrease the distance. And then we measure the current for the different distances. So first measure the distance, measure the distance between the electrodes. So between the electrodes, and then measure the current in the ammeter. Current in the ammeter. And then finally, repeat this. Repeat for multiple other currents, or I mean other distances between the electrode. So other distances between the electrodes. That's the method we use. Bullet point 2. State the key variables to keep constant. So the key variables. So the first one is going to be the power supply or the battery. So the battery or the power supply should be the same because we don't want to change the voltage in any way. So we can say the power supply should be the same. And next, what should be kept constant is the material of the electrodes. So let me erase this part. And the material. So if for the first part of the experiment, if the electrode is made of copper, the electrode should be made of copper for each one, or we should use the same electrodes. So the electrodes should be the same. Otherwise, it can affect the results. So electrodes should be the same. That's our second bullet point. For the third one, draw a table or tables with column headings to show how to display your readings. So we're going to have two columns. The first one is distance. And whenever we're drawing a table, we should always remember to put the units. So it can be in centimeters. And then nextly, we have the current, which is in amps. So this is gonna be our table headings. And then finally, explain how to use your readings to reach a conclusion. So what we need to do is we compare the results, or compare the distances and how they cause a change in current. So we just have to see how the change in distance brings a change in current. And then lastly, repeat repeat for each distances. So repeat for each distance and take the average. And take the average. So make sure to always write this part. It's just 3 marks. So the next one. This is about resistance. A student investigates the change in resistance of a lamp filament when the current in the lamp is increased. So the following apparatus is available: a power supply, a low voltage filament lamp, an ammeter, a voltmeter, and connecting wires. And other apparatus normally found in school laboratory is also available. So plan an experiment to investigate the change in resistance of the lamp filament when the current in the lamp is increased. So now we have to find out how the resistance in the lamp change when the current in the lamp is increased. So we have to find a way of changing the current. So resistance R is given by the equation R is V over I, where V is potential difference across the lamp and I is the current in the lamp. Draw a diagram of the circuit used. So we know we have a power supply, so we can draw batteries. And then next, we have a low voltage filament lamp, and we have an ammeter. So an ammeter is always connected in series with the filament lamp, or with the lamp, because we have to measure the resistance of the lamp. And then we have a voltmeter. So the voltmeter is always connected parallel to the lamp. So we have the lamp, and the voltmeter is going to be in parallel always. And then finally, so we have to find a way to change the resistance. I mean, to change the current of the circuit, because on the experiment we are looking to change the current and how it affects the resistance of the lamp. So to change the current, what we can do is we can use a variable resistor. So this is a symbol for a variable resistor. We use a variable resistor to change the current. So if we increase the resistance, the current decreases, and if we decrease the resistance, the current increases. So they're opposites. So that's the first bullet point. The second one, explain briefly how to do the investigation, including how to change the current. This part, including how to change the current. So the first one is we measure the current and the voltage, or the potential difference, And secondly, we have to calculate resistance. They've already given us the formula, which is R equals to V over I, using this formula. Next, we have to change the current using a variable resistor, and repeating the same experiment, and then repeat for different currents. So that's the methodology we have to use. The third point is draw a table or tables with column headings to show how to display your readings. So to draw the tables, we have two columns. The first one is going to be current, which is in amps, and next we have resistance, which is in ohms. So this is our table. And the next bullet point is explain how to use your readings to reach a conclusion. So basically, what we have to do is compare. We have to compare the current and the resistance. So compare the results of current and resistance to see how the change of current affects resistance. How the change in current affects resistance. And that's how you get the full 7 marks. So that was the last question. If you have enjoyed, make sure to like and subscribe. for more upcoming content. And that's the end of the video. If you have any comments, suggestions, or any questions relating to this, make sure to drop them down below in the comment. And thank you for watching.